Hi everyone. Does my mic work? Let's see. So I wanted to show you all something that I found that I thought was very interesting. I also wanted to say a little something about the document that dropped yesterday. So give me just a minute. Oh, it does look like I'm live. Yesterday. There we go. Okay. So what I found for today this is an older article called Forensic DNA Statistics Still Controversial in Some Cases. It looks like this was written in 2012. However, yes, December of 2012. However, when it comes to low copy DNA, there are still some techniques that are still used. And this one that I'm about to go over, I am curious to see if this technique is still used because it says here the frequency of the evidentiary profile is irrelevant when analysts are willing to include as possible contributors people like the defendant who do not have the profile. That to me says there is a way that you can, just like when law enforcement are putting in profiles into CODIS, they can use they have an option of how stringent they want to be. And when they put on a medium stringent, it will allow partial matches to pop up. Is there another mechanism where you can control what types of matches or possibilities are within that the analyst will consider? So when analysts widen the net to include people whose profiles do not match the evidentiary profile perfectly, the match and the evidentiary profile perfectly, the frequency of the evidentiary profile no longer reflects and will necessarily understate the likelihood that the innocent person will be included by chance. A few labs have tried incorrectly to deal with this problem by computing the frequency in the reference population of people who have the alleles that defendants share with the evidentiary sample. In other words, they tried to compute the frequency of people who would match the evidentiary sample the way the defendant matches. For the case illustrated in Figure 2, they would compute the frequency of people who have the defendant's genotype at locus D5S818 and locus DS820, and who have the 8 allele in combination with another allele at locus D113S317, but the net cast by this test has the potential to include a far broader group of people than those defined by the method that they were previously talking about, which we can go over again, but I just wanted to go over that this is an option that does happen. Suppose, for example, that the defendant had type 1313 rather than 813 at locus D7S820. Would he have been excluded? We strongly doubt it. We think that in that case, the analyst might simply have concluded that the 8 allele observed at the locus was caused by allelic observed at the locus at that locus that the 8 at that locus was caused by allelic drop in or by DNA of a second contributor. So when these analysts are predicting allele drop in and drop out, which ones are they choosing? Are they cherry picking which of these alleles that they say are dropping in and out? Or could it be something like, so this genotype for a defendant could be 1313 and the other one could be 813. But since there's, a similarity in the second spot, the 13s match here, then are you widening the search to include these other partial matches, but you're saying that the allelic drop in and out could account for why this first digit here is different than the first digit of our evidentiary sample. So then you're including someone in your analysis that might actually be completely innocent. Let's see if we can go up to see their figure 2 to see what they're saying here about the similarities. Here's figure 2. So the DNA profile of an evidentiary sample in a sexual assault case and DNA profile of a suspect. So then what we have here is the height of each peak in relative fluorescent units, RFU, is shown in the boxes below the labels for the peaks. So evidentiary specimen is on top here, and the defendant's reference is on the bottom. First thing I notice is that what scale are they looking at? And when you change the scales here, it changes a bit. So it looks like they're looking at different loci here. And these peaks, it looks like the defendant does have an 812. But when did that combination appear within the drop in and out? So I think that's very interesting that some of these so 812. See, they're very similar, but they are not. These are not the same. So there's that. And then, so analysts are often reluctant to exclude a suspect unless there is no plausible way to account for discrepancies between his profile and the evidentiary profile. So when the analyst can invoke allelic drop-out, drop-in secondary contributors and various other explanatory mechanisms to account for these discrepancies. However, the number of profiles that might plausibly be consistent with the evidentiary sample can expand rapidly. This means the net cast by the test is far broader than the category of individuals who match the way the defendant matches. There's a subtlety there, and I do believe that since MPD was under pressure to make an arrest, they would have made a decision like this when analyzing DNA to widen the net to other types of profiles that are plausible with different combinations of allele drop in and drop out. And this is done because it has a lot to do with the bias in our system. And as we were learning from Cy Ray and Tiffany Roy, that there is an inherent bias in the system, in the adversarial system. So a lot of times these experts, they're looking for any type of connection, whether they can explain it away or not, because you don't want to be on the other side of that adversarial system at times. And so a lot of these experts, they never work with the defense. They never really have a wide experience of the system as a whole. They know one part of it. And so they make these types of decisions. And in this case, I think it's highly likely that whatever DNA they have, they made these types of exceptions that made the DNA inaccurate. However, the number of profiles that might plausibly be consistent with the evidentiary sample can expand rapidly. This means the net cast by the test is far broader than the category of individuals who match the way the defendant does. Another approach labs have taken to address this problem is to base statistical computations only on loci where all of the suspect's alleles were detected in the evidence, ignoring the statistical purposes, any locus where the suspect does not match. That would be, I think, exculpatory evidence if any of the analysts ignored areas of the defendant's DNA profile that didn't statistically match. But two prominent experts of forensic statistics have recently published an article calling this approach unsupportable. Using statistical modeling, they showed that this approach may produce apparently strong evidence against a surprisingly large fraction of non-contributors. It allows labs to ignore potentially exculpatory results, the loci where the suspect does not perfectly match, while counting against him those where he does match, and this cherry picking of data greatly expands the net cast by the test in ways that are not adequately reflected in the inclusion statistics, such as approach answers to substantially different question than the one addressed by the random match probability. It essentially asks, what is the chance that a random chosen individual from a given population would match the defendant if we focus only on the evidence consistent with a match and ignore evidence to the contrary? When analysts present such statistics to the jury, however, they typically and misleadingly describe them as random match probabilities. The fundamental problem facing those who try to design statistical procedures for such cases is that no one knows how broad the net cast by the test really is. Estimating the percentage of the population who would be included as a possible contributor is like estimating the length of a rubber band. Just as a rubber band may be longer or shorter depending on how far one is willing to stretch it. The size of the included population may be larger or smaller depending on how leniently or strictly, the analyst defines the criteria for an inclusion because it is unclear just how far the laboratory might stretch to include a suspect. The true size of the included population cannot be determined. In some cases, forensic laboratories try to deal with this problem by using statistics known as likelihood ratios rather than frequencies and random match probabilities. To compute a likelihood ratio, one estimates how probable the observed results in the evidentiary sample would be if the defendant was and was not a contributor. Because the likelihood ratios focus on probability of obtaining the exact results observed under different hypotheses about how they arose. They avoid the difficulty of estimating the size of the included group, but they run smack into a related problem. To compute an accurate likelihood ratio in a case like shown in figure 2, which we looked at, we'll look at again later, one must know the probability of the allelic drop out and drop in, the probability of that allelic drop out occurred. Without knowledge of the drop out probability, one cannot know the probability of obtaining the observed results. If the defendant was a contributor, which means one cannot compute a likelihood ratio, at least not accurately. It is well understood that as the quantity of DNA in a sample decreases, the probability of drop out and drop in increases. But as the quantity decreases, the ability to reliably estimate its quantity also decreases. So we're talking about the trace DNA that was found on this button snap of the knife sheath and the pressure MPD was under, and what kind of leniency did they put on their search criteria. This particular method that we are talking about here is one that is known, and there is literature on it. And so, again, when you have the quantity of DNA, the genetic material that is as little as trace DNA, it's very difficult to reliably estimate the probability of the drop in and the drop out. And they're often more than guesses, which we find unacceptable given that the results of the DNA test, whether it is reported as a powerful, incriminating, or a definitive exclusion, may depend on what guess the experts happen to make. In 2006, a DNA commission of the International Society of Forensic Genetics proposed a statistical method that takes dropout probabilities into account when computing a likelihood ratio. Unfortunately, this approach is difficult to apply even in simple cases due to uncertainty about drop in or the dropout probability. Matters quickly became even more complicated when formulae incorporating dropout probabilities are applied to mixtures. The Commission acknowledged that expansion of these concepts to mixtures is complex, and that is why they are not generally used. But that, of course, leaves forensic DNA testing in an unsatisfactory position of having no generally accepted method for computing statistics in such cases. Oh, hello, Heather Fitzgerald. It's so good to see you. Hello. And oh, Chloe Penny. Oh, it's very nice to see you. Aw, welcome. You argue with people daily? Oh, I'm so happy you're here. Right. People just, they don't understand these major issues with the DNA evidence. Oh, I'm so happy you all are enjoying it. That's great. So good to see you. I found that this document is older, but it has techniques in there that I do believe are still used. And the one thing about DNA, and I know in science as a whole, they always say you need the newest information out there. However, with the low copy DNA and what's so difficult and unreliable about it, you can sometimes, I was told by my professor, sometimes it's okay to get a little bit older of an article, but you have to make sure the information in that article is still current. Then you're able to use it. And sometimes in DNA, there are older articles that you can reference because of the information in there. And the low copy DNA, the drop in, the drop out, the ability to widen your parameters of what you're searching for, these are techniques that are still used. So even though this article is a little bit older, it is still very relevant because these things did occur and they do occur. And so it's very, it'll be interesting to see what types of decisions these DNA analysts at the crime lab, the Idaho State Crime Lab, made. How wide did they widen it? Did they find somebody that is really not a match? I hope we find the answer to that. And I do want to keep reading about this article here. I think I'm going to read for another minute or two, but then I got to go. I just thought that this was amazing that analysts are including innocent people where their profiles are not matches. Okay, so a more defensible way to deal with problems arising from stoic effects is for the lab to ignore, for statistical purposes, any locus where it is suspected that stochastic effects leading to dropout may have occurred. How can you ignore that? That completely changes the sequence of things. But anyway, that it does happen. These stoic effects and drop in and drop out are still very, very hot topics today in DNA. So one clue to whether the sample in question is subject to stoic effects is the height of the peaks seen in the phonogram. The peak heights are measured in relative fluorescent units, RFU, and their height can be determined by reference to vertical indices on the electrophonogram. As a general policy, some labs ignore statistical purposes any results that the locus where the peaks below a stochastic threshold, which is often set somewhere between 50 and 150 RFU. I think there are some issues with interpretation here. It's all down to people as how these people interpreted the DNA on the snap. Absolutely 100% Clopenny. Yeah. Bico Barlow added that part from the inside the cell for a reason. Yes. Because it had nothing to do with the IgG. Yep. Yep. Definitely. So now different labs, because it's not standard across all labs, they may not even have a policy about stoic effects. But a lot of times there should be a level where you're like, okay, we're getting too close to the stochastic effects with the drop in and drop out. We should have a level where we cut off, where we're not able to say reliably if these are matches or not. So I don't know if between 115 RFU is still accurate, but they're still having these issues. So again, this is an older article, but the information in here is still good. So stochastic thresholds are not a perfect solution to problem posed by unreliable DNA data because it means the lab may ignore potentially exculpatory data such as the mismatch seen at locus D13S317 in figure 2. And experts disagree about what the stochastic thresholds should be. So let's take a look at that. Figure 2, they're saying there is a mismatch in this one that's S17. Here we go, the middle one. So they're saying that these could be similar, but it's this person clearly is not a match because at the locus D13S317, their peaks are completely, there's something different here. This is not a match. So I see what they're saying. And so some analysts may not include this information when talking to the jury that this person actually did not match. And these allelic drop in and outs have severely affected whatever these experts are saying this profile actually is. And experts disagree about what the stochastic threshold should be, but this approach is less likely than other approaches to produce results that are unfairly biased against the suspect. Unfortunately, the conservatism of this approach is the very reason that many laboratories reject it. This approach reduces the impressiveness of the statistics that can be presented in connection with a DNA match. When there is no valid way to compute a statistic, or when the only valid method produces statistics that are modest and unimpressive, labs sometimes elect to present DNA evidence without statistics. The jury is told that the defendant's profile matches the evidentiary profile, or the defendant cannot be excluded, but is given no statistics that allow them to assess the strength of this evidence. This approach violates the particular body's guidelines, as well as the legal requirements in many jurisdictions that DNA evidence is admissible without statistics. Defense lawyers sometimes raise no objection. However, thinking that without statistics, the DNA evidence will do less harm, and fearing that an objection may prompt the government to generate a statistic that will prove more incriminating, the danger of this approach is that even the absence of statistics, the jury will assume that the DNA evidence is highly probative, which could easily cause the jury to overvalue the problematic kind of DNA evidence we are discussing here. And even in the Kohlberger case, there's a reason why the state has never said what type of DNA they have. They are not going to admit that they have the weakest type of DNA that may not even be accurate. If they had blood, sweat, semen, that kind of thing, that would be posted all over the news, and they do not. So I wanted to get on quickly and show you this. I want to go over it again. I'm on my lunch break here. I was excited, and I also wanted to say that with the last drop that we had yesterday, the state has admitted they did not use the required information they needed to make the allegations in the probable cause against Brian Kohlberger in the times and the locations that are in that probable cause. Otherwise, they would have put that information in there. They needed to put the stuff that they have in there. But now all they're saying is, all we said was that he was in the vicinity of a tower. That's the entire town. The entire town was in the vicinity of a tower. So if you don't have legitimate information to get a warrant, how and what did Brett Payne use to get that second AT&T warrant? And if Brian Kohlberger was not on the towers he was looking at, how did he get probable cause to get a warrant? And the one thing that Cy Ray said, he said specifically in this case, not only does he need the tower list of the tower lists that were used and how they relied on that information that they used, he also needed the tower list of the actual towers the phone was actually communicating with. So it's always been my contention that Brett Payne, he never saw Brian's phone on the towers he was looking at because the phone was connecting to other towers. And this is another one of those things where they were under pressure, they had blinders on, so he's not going to look at other towers that potentially the phone connected to. He's only going to look at the ones that are important to him. And I think that this is definitely going to hurt the prosecution because they have basically admitted they do not and they have not had the information to support the information they put in warrants to continue this investigation. So, oh my gosh, hello, American Princess. Chloe Penny, you have to wonder what type of DNA those other samples are, the three unknown. Exactly. And if they were willing to put blinders on, you never know how closely they actually matched. Exactly. It doesn't mean anything. He could have been in his apartment and pinging off that tower. Yep. They lied to get those warrants. Yes, they did. Talking towers and a twizzle stick will appear. Twizzle stick. That's really funny, Heather. I am so looking forward to those motions to suppress too, because Masseth would not have brought up Frank's material if she did not already know that there is Frank's material and there is documentation that the Brett Payne misrepresented himself. He misrepresented himself where not only did he not have the required information to obtain that second AT&T warrant, even when that information did come back, it still did not provide incriminating information. And I think that's what people are missing here. And I think people are missing the role mainstream media was purposely meant to play in this case. The mainstream media has a relationship to this case, and it's to fill in the gaps where Brett Payne failed to fill them in. However, you can't have that. That's not how our system works. Brett has to follow the law in order to pursue someone. And in this case, I don't think he did. I think we're going to see the motions to suppress. There might even be some perjury things coming. People need to realize Brett Payne lied in the information. And that's fruit of the poisonous tree. Do I see a Miss Annie Potts? Welcome. Oh, so good to see you, Annie. Masseth is my spirit animal too. Oh, you're so funny. I love it, Chloe Penny. Oh, Sarah D. Irish. So good to see you. Wow. Well, thank you guys for coming by. Definitely rewatch it if you get a chance. Hopefully, I could probably go over that again. There is another part of this article that I want to go over because we don't know if the state lab used just from observing the drop in and drop out of the alleles, or if they use this software that we've talked about the software too, this genotype software, but even then there's limitations there too, where there is bias built in, and they do have some of these techniques that also exclude exculpatory evidence as well. Masseth wants to suppress warrants, specifically the one used to obtain the most crucial piece of evidence in that case. Right. Payne misrepresented himself, and Masseth would not have said that unless she can already prove it. So yeah, this case, buckle up, everybody. This case is about to get fiery. The more it comes out that the state failed to do what they were supposed to do. Keep it up, Audrey. Oh, thank you. You're so sweet, Chloe Penny. So great to see you all today. This is all I have right now. I gotta go. I'm gonna get on after I get off work, but I also, before I went, I am gonna be on Excited Utterance tonight. She is gonna have my very close friend and a Twitter favorite, Commercial Zone, Kathy from Commercial Zone. That is going to be, I believe, 9 Eastern Standard Time. So stop by Excited Utterance to hear Kathy Commercial Zone. I will put the link in the description, and I'm excited to see all of you again when I get off work, and then again later at Excited Utterance to see Kathy Commercial Zone. Oh, I love you too, Miss Potts. Oh, bye everyone. I'll see you next time.